Hi, and welcome to my video demonstration for Assignment 5 Research Implementation. For this project, I chose the paper Line Rendering in Loose Style for 3D Models. So before the demonstration, I'm just going to give a quick overview of the paper. So what is line drawing? Line drawing is a non-photorealistic method, and it can be classified into three groups: precise line, loose line, and abstract style. Precise line rendering techniques are very well researched, while loose and abstract require a lot more research, and that's where this paper falls. For the technical implementation of this project, there are four stages: pre-processing the curvature, drawing the silhouette, controlling the thickness of this silhouette outline, and also omitting areas of this silhouette. In this project, the pre-processed curvature is represented as a texture. An example of this can be seen on the right. This bottom image on the right was taken directly from the paper and identifies areas of high curvature and low curvature, black being areas of low curvature and white being areas of highest curvature. In order to draw the silhouette, we draw the model in white and we cull the back faces. We then use a geometry shader to move each vertex outwards along its normal, and we draw this new shape in black and cull the front faces. To control the thickness of these outlines, we can control the distance along each normal that a vertex is moved. That distance is related to the brightness and curvature at each vertex. We can then omit lines based on areas of high curvature or high brightness. For this project, I could not get accurate pre-processed curvature maps for each model, so instead I used these two different textures. One on the left, which is a checkered texture, shows a very flat curvature or extremely high curvature. On the right, we get a more gradual variation of curvature levels. On the bottom, you can see outlines of varying thickness and line omission. You can see lines are omitted in areas of high curvature, such as the white areas on the checkered texture, and thick lines in areas of low curvature or low brightness. When evaluating these results, it is immediately clear that there is a need for an improved curvature texture for the models. However, this shader program correctly follows the criteria set out by the paper for loose line drawing. We can also see that this method struggles for simple shapes such as cubes. The issue here arises when moving vertices along their normals. We simply create 6 new faces. These are moved further apart from each other and do not create an outer mesh. This does not create a realistic or believable outline. It can be seen here on the right. Now we can see the real-time rendering implementation of the shader program for this project. Here we can see different models with different curvature maps and how the results show. Here you can see the variation in line thickness and line omission based on the curvature map and the brightness. There is lots of line omission where the texture is white. Here we can see line omission on the chest of the bunny, as that is the lightest part of the curvature. Elsewhere, lines are thicker where they are deemed to be flat, such as on the ears. The bunny's back is a thin line due to the lighting model. Here we can see lots of line omission on the bunny due to the high areas of curvature in the texture map. The limitations of this technique can be seen here at the tops of the model, where there are simple flat shapes. You can see the edges don't quite create a perfect silhouette. Overall, the real-time rendering method implemented here meets all of the criteria for loose line rendering. Line thickness and line omission are correctly rendered for the texture map and lighting models provided for this project. This effect was created using GLSL and C++. This effect can be applied to many different types of 3D models. Here we can see an example of the GLSL loose line rendering method applied to different models. Here the checkered texture is used as the curvature map. Thanks for watching.